Good afternoon, good morning, everybody. It depends where you are. My name is David Levy-Four, and I'm here hosting the seminar with Nir Kosti. We are happy to have you. You probably all of you know the seminar and are aware of its goal, but let us say that again. What we are trying to do is to look at the metrics of regulation, looking at various measures that can help us to capture the complexity, the multidimensional aspects of regulation, from surveys of public opinion until performances of the system itself. And the system itself is also, it's not one dimension. Let's say the system itself can be characterized, for example, like in today, like by its complexity, and the regulatory complexity needs to be sought, conceptualized, measured, and so on. And this is the topic of today's seminar. But it's in this context of how to do a better research on regulation, but better research, but also better regulation, right? Policy implications. Nir Kosti is my co-host of this webinar. And Nir, do you want to say a few things before?
Yeah, so we're focusing on some key questions in the measurement of regulation, how we can assess, for example, regulatory growth, how can we more effectively describe the content of regulation, how can we better understand public opinion about regulation, and much, much more. And the issue is that the thing is that measuring regulation is quite challenging, and the field remains in its quite early stages of development. So that's exactly why we are here today, and we are very happy to explore today the theme of regulatory complexity. But before starting, we need to describe or to provide a short bio of our speaker today. David, would you like to?
Yeah, I can do that. I would say that with us is Jean-Edouard Colliard, an associate professor of finance at HEC Paris. He has a PhD in economics from 2012 from Paris Schools of Economics. He has worked 2 years as economist in the research department of the European Central Bank, the ECB. He studies regulation of financial institutions and microstructures of financial markets, including topics such as financial transaction taxes, over-the-counter market, bank capital requirement, or the European Union European Banking Union. Now, what is presenting here is a work with Copier Georg. So thank you so much, Jean-Edouard, and you can correct me if I was wrong in any of the descriptions. So thank you so much.
That was perfect. Thank you very much.
Good.
Thank you very much. Thank you, David. Thank you, Nir, for the invitation. Very, very well appreciated. And I'm very glad to present our work to this audience. Okay, so I guess you can see my slides. Otherwise, you tell me right away. All right, so I'm really looking forward to your questions, your feedback, your comments. So don't hesitate to interrupt me as we go along. This paper is titled Measuring Regulatory Complexity. It's joint with Copier Georg. As you will see, perhaps the title is a little bit too general. We are finance professors, and so I'm going to mostly talk about an application to financial regulation. Okay, but the tools we develop can also be applied to other forms of regulation and other types of complexity. Okay, so this is the roadmap. It's a very long paper, like we like to do in finance and economics. So I have a lot of things to say. Maybe I won't cover everything. If I can't cover everything, I think that's okay. I will focus on what's maybe the most interesting for you. Okay. Just a bit of motivation. So you may or may not know that there is a big, I mean, of course, we care about the complexity of regulation in many applications, in many industries. But in finance, there is really a huge debate about this. Okay, so everybody has been talking about the complexity of regulation in finance. The industry has been complaining a lot that financial regulation is too complex, but even regulators actually have said that it's too complex. And so, there are some very, numbers that are circulated. And, for instance, people talk a lot about the Basel rules, so the international standards for banking regulation. And from 1988 to 2014, they have increased from 30 pages to more than 600 pages. So it's a very, very simple measure of complexity, if you want, but clearly, there is something that's going on. And of course, as usual, there is also a lot of lobbying for simpler regulations. In the US, actually, they enacted some policies to try to reduce the complexity of regulation. Now, with the Trump administration, there might be a very drastic, actually, reduction in the amount of regulations and so on. So it's really something that, that matters a lot. Okay, I'm sure this is true in other industries too, but in finance, the stakes are very big and the debate is very heated. Okay, so much so actually that in 2013, the Basel Committee on Banking Supervision, which is an international body that writes the Basel rules, so the standards for bank capital regulation, they acknowledge actually that there was a trade-off between, how precise, if you want, the regulation can be and how complex it is. Okay, and that maybe we had reached a stage where the complexity of regulation had become a bit counterproductive, and that it would be nice to have regulation a bit simpler, even at the cost of being a bit less precise. Okay. The issue in this debate is that, well, conceptually, I think this was clear to everybody, that potentially there is such a trade-off. But how do you operationalize this trade-off? You need to have a measure, okay? And so this is where we try to contribute. How can we think about measuring the complexity? Just an example of the kind of charts, that people like to circulate in banking, just to illustrate how complicated the regulatory system has become. Okay, so these are a chart about the US banking regulation with all the different agencies here and all the different types of banks and so on. And this chart is actually produced by a consulting company that, of course, offers to explain to bankers, how to navigate the complexity of the regulation. Okay, so there's also a whole industry basically behind it. Okay, so what's our approach? So we try to develop a toolkit to quantify the complexity of financial regulation. And then we test if our measures align with, how different how humans perceive complexity. That's why the paper is a bit rich, if you want. So there is a part which is a bit more conceptual, where we try to explain, what do people mean by regulatory complexity, in particular in the context of banking. Then there is a measurement part where we measure the actual complexity of different regulatory texts. There is an experiment in which we try to see whether, experimental subjects have a behavior that aligns with our measures of complexity. And there is even now an empirical exercise where we rely on a survey to test whether our measures are correlated with what people say in the survey. Okay, so that's due to the referring process in finance, where you are asked to do more and more and more and more and more. But so that makes the paper perhaps even a bit too rich. Okay, I see something in the chat. Okay. All right. So the way we do this is that we draw an analogy between algorithms and regulation. Okay. So for an algorithm, so we take, so basically if you can think of an algorithm as, a set of rules to go from an input, which could be, a number or some parameters or whatever, some data, and you arrive at some output after a sequence of operations. Okay. Regulation, you can think of it exactly in the same way. In our context of banking regulation, this applies very well, actually. A lot of banking regulation is about computing capital requirements. What do you do when you compute capital requirements? You take a bank balance sheet as an input, you apply a number of rules, and then you arrive at a number which is the amount of capital that the bank needs to have in order to operate. Okay, and so it's pretty much an algorithm. And actually, I'm going to show you an example, which is the Basel I regulation, which works very much like an algorithm. Okay, so this analogy is not new. I mean, there is a literature in law, and I'm sure in political science, that uses a little bit the same comparison or the same metaphor, if you want. But you can tell me actually if there are some important references that we are missing potentially. But we think that we are really taking this metaphor, if you want, very, very, very far. Okay, because we're also going to validate the measures exactly very much in the same way that people do in the computer science literature. We really try to exploit as much as possible this idea that you can see the regulation as an algorithm. Okay. All right. So what does that deliver? So first, we distinguish different dimensions of complexity. Okay, so David asked me to not bother you too much with theory, so I will stick to a minimum. But I think it's important to distinguish, before we start measuring stuff, to make sure that we know exactly what we want to measure.
The complexity is very important. What is complexity is very important. Take your time on complexity.
Exactly. So I'm going to start with that because my experience, you all work on complexity, so you are familiar with these issues. But when I present this to a finance audience, the typical feedback I get is, oh, you are measuring this, but for me, complexity is rather that. Okay, and so everybody has like their view of what is complexity and what is not complexity. And all these views are just different dimensions, basically. So it's just important to know, what are these dimensions and what are we talking about. And so, of course, I cannot measure all of these dimensions. We think that, we have measures that are interesting to capture some of them. Okay. All right. So, so the way we do this is that we propose a measure which is based on classifying words in a document according to their algorithmic function. Okay, so here we rely on early work in the literature on algorithmic complexity, and so we develop some measures. I'm going to show you the details in a moment, and we really see that as a cooperative effort. So we provide online all the codes we use, the dictionary, everything, so that other people can jump in. Actually, we already applied our method to some other applications. So we have a very short paper on the complexity of tax rules. If some of you work on taxation, maybe you can have a look. My co-author has a paper on the complexity of cybersecurity regulation. It's a tool that's not specific to finance. It can be applied to other things. However, the dictionary that we put online is specific to finance. Okay, so if you want to apply this to other fields, you will need to enrich the dictionary a little bit. Okay. There is a very interesting literature on complexity in economics. If you are particularly interested, you can ask me about it later on, but let me maybe skip that for the moment, for the sake of time. Okay. All right. So let me jump into what we do and our framework. Okay. I see there are things in the chat. If you have a question, I prefer, if you can just ask me directly, I think that's much better. Don't hesitate to just interrupt me. Okay. All right. So the framework. So this is, in summary, what we have in mind. What we have in mind is that, basically we have if you look at the paper, we have a very simple economic model, a microeconomic model of the regulatory process. Okay. So this model is just summarized here. So I just want to give you the main intuition. So our idea is that, you start with a certain, regulatory problem. Okay. So for instance, you have banks, you think they are too risky, and you need to have some regulations to ensure that the financial system is stable. Okay. So see that as a kind of maximization problem. Okay. So you want to maximize the stability of the system, but also you don't want to decrease economic activity too much. Okay. So you ask, regulatory authorities to propose a regulation. And so they have an idea of what's the best regulation that they would like to implement. Okay. And this regulation, we call it FI. Okay. So it's the ideal regulation that regulators would like to implement. Okay. After having considered all the pros and cons of different rules. Okay. This FI, you can think of it as a function that goes from, I give you a bank, you give me a regulation. Okay, so it's a function that transforms a bank into some rule that applies to the bank or some capital requirement. Then there is a first stage, which we call the drafting stage. Okay, so these regulators, they know what they want to do. They have to explain this on paper. Okay, they have to write a regulatory document, a text or a law that just explains, how the bank is going to be regulated. Okay. So this regulatory document is a text which we call big F. Okay. Now, in reality, of course, it could be that this document has mistakes, that you thought that you were implementing a certain regulation, but actually what you describe is something different from what you have in mind. Okay, maybe it has loopholes, or maybe you described something which is not exactly what you had in mind. Okay, and so there is potentially a mistake. So how do you see a mistake on this graph? So you start with this ideal regulation phi. Okay, you draft a certain text f, then the I of f is the interpretation of this text. If you draft the text correctly, then the correct interpretation of the text is the phi that you wanted. Another possibility is that you write a text, but the interpretation of this text is different from what you had in mind. It means you made a mistake at the drafting stage. Okay, and so we think that, so we just call mistakes at this stage. We think they are related to what we call intrinsic complexity. Okay, you want to write a regulatory text about a regulation which is intrinsically complex, and that's why maybe you make a mistake when you draft your regulation. Okay, so that's the first stage. We call it the drafting stage. Then there is a second stage, which is you have this text F, and the text is actually a correct description of what the regulator wanted to do. Okay, so the regulation is correctly drafted. But then, regulated agents or supervisors, whoever has to implement this regulation, they need to read this text and they need to interpret it. Okay, and again, there could be mistakes, or there could be a cost of interpreting this text correctly. Okay, we call this psychological complexity. There is a text, it could be very easy to understand or very difficult to understand. Okay, but that's something a bit different from intrinsic complexity. Okay, it could be, for instance, that you want to implement something which is very simple, but the way you describe it is very complicated. Okay, or potentially it could even be the opposite, that you try to do something that intrinsically is very complicated, but you manage to explain it in a very simple way. Okay, maybe that's less intuitive case, but in theory, it's possible. Okay, so that's a second dimension, which we call psychological complexity. See that as the difficulty of interpreting a regulatory document. Okay, and finally, there is a third stage, which we call computational complexity, and which is closer to most of the work in algorithmic complexity, where, once you have the rules and you have understood the rules, you need to actually apply those rules. For instance, for a bank, you need to actually compute the capital requirements on that particular bank. Okay, and so again, it could be the case that, for instance, there are many rules actually that are very simple, but just when you apply them on a particular bank, you need to consider many different assets, many lines in the books, and that's just very long and very complicated. Not for fundamental reasons. There is nothing like intellectually complicated, if you want. It's just computation time is high, if you want. Okay, and that's a third dimension that we call computational complexity. Okay, and so these three things are a little bit different. You might have in mind, even other dimensions. That's totally fine. These are three dimensions that we think are important in the context of banking regulation, and we try to capture the best we can with different measures. Okay, and so in particular, I think from a measurement perspective, for the empirical analysis afterwards, what's very important to realize is that these measures are really, not only these are different dimensions, but they are also about different objects. Okay, because intrinsic complexity is the property of the regulation, but which is the idea of a regulation, if you want. Okay, so for instance, you can have, you can decide to regulate banks using internal models or using pre-specified rules. These are two completely different ways of doing the computations. Okay, so these are different files. This is a bit independent of the way you describe those things. Then you have psychological complexity. It really depends on the text. Okay, it's the complexity of an actual text. In particular, if I take the same regulation and I describe it in two different texts using different words, using a different structure or whatever, the intrinsic complexity is going to be the same because it's the same regulation. But the psychological complexity is going to be different because it's our two different descriptions of that regulation. And finally, computational complexity, you need to know not only the text, but also the economic entity to which the regulation is applied. Okay, so for instance, it could be that you take certain rules, in banking, for instance, a lot of rules apply only to large banks and not to small banks. Okay, so it could be that a given rule to compute capital requirements is intrinsically complex, but the computational complexity for small banks is 0 because small banks are actually exempt from that particular rule. Okay, so that would be a particularly simple example, but just to illustrate. Okay, so not only these are different dimensions, but they even apply to different objects. Okay, so that's something important to keep in mind for the measurement. Okay, is it more or less clear so far? Any question? No, don't hesitate to interrupt me.
We have one question in the chat.
Yes, okay. Computational complexity seems to mean the complexity of regulatory accumulation. Each new regulation adds to the complexity of all existing regulations. That would be one example. It doesn't have to be the case. Okay, so what's true is that if you keep adding new regulations, actually all dimensions need to increase. That's actually a good test of a measure, right? So if you for all these dimensions, it has to be the case that if I just add new texts, in principle, all these measures should increase. If that's not the case, there's potentially a problem. And now let me correct that right away. One counterexample would be, imagine, so this happened in the past. For instance, you have a certain banking regulation, and you pass a new regulation that says, okay, for certain banks, we are going even further, but for the others, actually, we exempt them from a lot of rules from the previous regulation. Okay, so here computational complexity would go down with the new regulation. Okay, the first two are outputs. The last one is an outcome. Okay, again, so let me reiterate. So the first one, intrinsic complexity, we are aiming at capturing the complexity of the regulation you want to implement, of really the mapping between a regulated entity and the way it's going to be regulated. The second one, it really applies to a text. We want to know whether this text is easy to understand or not. The third one is about a particular regulated entity. You want to know whether for that particular agent, it's actually costly to implement the regulation. Okay. And again, these are slightly different. These are different dimensions. You could very well imagine the example of a regulation where the text is very difficult to understand, but actually applying this text to one particular bank in my example could be very easy. Okay. So in principle, the three things need not be the same. Okay. All right. Rennie, yeah, you can think of it this way, exactly. Okay, so computational complexity is really going to be for the implementation once the regulation exists. Yes. Okay. Okay, this was maybe very conceptual. So let me, show you a bit the measures and some examples, and maybe that will become clearer. Eric, yes, please go on.
Yes, thank you. I'm working for a number of years for the European Commission on different better regulation files, and I was prior to that in academia, and I still have a foot there. But one thing is striking, complexity. Well, here we have 27 member states, a lot of regions, and the administrative capacity to understand regulation is quite different from when you look at different member states. So how do you compute in the capacity of the recipient of a regulation? Or a long time ago, I was in charge of the Cutting Red Tape program, and we have a number of companies for which this was no-brainer, and others did not have the same resources. So that dimension, how do you compute that, the human dimension of the capacity to tackle complexity? Over to you.
So it's a very good question. The answer is simple. We don't compute this. Okay, so it's not one of the. Again, there are many different dimensions to this problem. That's not one of the dimensions that we can tackle. Okay, I'm going to show you exactly what we do. This one is super interesting, but we just don't do it in that paper. Okay, sorry for disappointing you. But the point is well taken. This is obviously super important. Okay, thank you. So measuring the complexity of algorithms. Okay, let me now be more, really go into the measurement. Okay, so because our idea is really to rely on this parallel between regulations and algorithms, so as a kind of proof of concept, we use the first measures of algorithmic complexity that have been proposed in the computer science literature, And so that measure is particularly simple. So this is due to Halstead in 1977. Halstead, he says, well, you can see an algorithm as a list of symbols, if you want. And so some of them are operands and others are operators. Okay, so mathematically, an operand is like a variable, a constant, and so on. And operators could be, mathematical operators like plus, minus, equal, or logical operators like if, for, and so on. Okay, and so of course, what you do in a computer program is that you perform operations, and so an operation is typically applying an operator to an operand in order to generate a new operand, which is the output. Okay, and so again, I think in the context of regulation, that kind of makes sense. Okay, so the operands are going to be, the different elements in the balance sheet of a bank, the different risk weights you apply to these elements, and so on. And the operators are going to be, some mathematical operators, but maybe also, some words that indicate that the bank needs to do something, and so on. Okay, so we keep the same idea. We go a little bit further because, regulation is a little bit richer than a mathematical algorithm. And so we distinguish, we keep, logical operators and mathematical operators. Okay, so those already exist in a computer program. We also add regulatory operators. And so the idea here is that if you look at a computer program, there's always going to be, the symbol equal, okay, which tells you this is the output, okay? The equivalent in a regulation is a word like should, for instance, right? So that says, this is the word that indicates that there is a rule and that the bank has, or, that the regulated agent has to do something, okay? So that's the equivalent of equal in a computer program. It signals that now we are talking about the output, okay? All right, let me give you a mathematical example, okay, and then I'm going to show you some text afterwards. So imagine that you want to compute the absolute value of a number, okay? So the algorithm to compute the absolute value of a number, you could write many algorithms. This is one which is particularly simple, okay? So you say if x is greater than 0, then y is equal to x. If x is smaller than 0, then y is equal to minus x. And so the output will be the absolute value, okay? We can compute the number of operands and the number of unique operands, okay? So what are the unique operands? We have x, we have y, and we have 0, okay? So we have 3 unique operands. In total, we have 8 operands because x appears twice, appears 4 times, 0 and y appear twice. We can look at the number of operators, okay? So you have this equal sign with 3 bars, okay, which indicates that now we have an output. So we have this one. It appears twice. And then we have logical operators and we have mathematical operators. And so, okay, so in a computer program, you can easily compute this type of measure. Okay, so here already we define 2 measures of complexity that are very simple. One which we call quantity. Okay, so quantity simply the number of regulatory operators that you are using. That's the number of rules in your regulation. Okay, the number of different rules. In a computer program, that would be the number of outputs that you are computing. Okay, in a regulation, it's going to be the number of rules. We call this quantity. You have length, that's very simple. This is just the total number of operands and operators that you have in the program. Okay, so that's very simple. Something more interesting and which we think is really the very cool idea in this Halstead 1977 book, actually, is what we would like to do is to have a measure of intrinsic complexity. Okay, remember, I had these different dimensions, and psychological complexity, you can say, well, I can look at a lot of things. Okay, I can look at the text, I can compute the number of words, I can compute the number of difficult words, I can compute the richness of the vocabulary. I can do, a lot of things that are more about linguistics, if you want. Okay. But intrinsic complexity, okay, if we want to say, well, look, it's not necessarily that the text is complicated, is that what the text means, what the text is after is something complicated, okay, something more intrinsic that does not depend on whether the text is well drafted or not, okay? That's more challenging. And so the idea and Halstead, it was exactly after the same question. It said, okay, you have different codes to compute something. Okay, maybe the code is very complicated, but maybe that's because the way you write the code is very bad. Okay, maybe this has nothing to do with the underlying algorithm. Maybe the problem is that just you are a bad programmer, okay? So how can we measure, based on a text, intrinsic complexity that should not depend on the way the text is written, okay? That's almost paradoxical. And so the idea of Halstead was very simple. He said, okay, in the context of coding, what you could do is say, okay, is to measure the length of the shortest program in the best possible programming language. And so it turns out that we know what this is. For instance, if you think about the absolute value, okay, the way you would do this in an actual computer program is that you would just call for a built-in function, absolute value, okay, y equal abs of x, okay? That sounds very tautological, but actually it's not, okay? Because at the end of the day, you can count, the number of symbols in this program, and you are always going to have the number of inputs and the number of outputs. So fundamentally, what Halstead is saying is that, well, a measure that's invariant to the way you are coding the program is the number of inputs you have in this problem and the number of outputs that you want to have, okay? No matter how you code the algorithm, if you want to have, a code that returns 10 outputs and it takes 20 inputs, then you are going to have at least these 30 elements plus the equal operator, okay? And there is no way you can do better than that, basically, okay? And again, that sounds very simple. In the context of regulation, I think this is actually super interesting, okay? This is just saying, you could count the number of unique operands that you have in the regulation, and that already tells you something deep about that regulation, okay? So if I have a regulation that, just mentions banks, I know that in a sense, this has to be simpler than one that also mentions insurance companies, over-the-counter markets, OTC derivatives, or whatever, okay? So the more concepts and the more economic entities you add to the regulation, probably the more intrinsically complex what you are trying to do is, okay? Regardless of the way you actually draft the regulation, okay? So we keep this idea and we call this measure potential volume, like Halstead called it, okay? So at the end of the day, it is just the number of unique operands in the regulation plus 2, but let me skip the explanation for why it's plus 2. Let me also skip the level because it's we don't find that it works very well in the data, so let me skip it, okay? If you look at the paper, we have this table where we survey the literature for us, and so we try to classify different measures into what they are capturing. So I think the takeaway from this is that it's really important to distinguish 2 dimensions. So one is, here we are really in the realm of text-based measures, okay? So we are going to take the text of a regulation and we want to compute measures of complexity based on this text, okay? In the finance literature, and I'm sure in many other literatures too, there are also many measures that we call outcome-based, okay? So you can directly measure, for instance, the compliance costs for companies, or you can measure how many compliance officers do you have, or how many hours does it take to fill a particular form, and so on, okay? What's important to realize is that these 2 types of measures are complementary, okay? Because if the goal is to, for instance, improve the way regulations are drafted, okay, so to improve the regulatory process, you need to understand what makes a particular regulation complex. And so for this, you need to measure the complexity of a regulatory text, okay, or of a regulation. However, in order to check that this is indeed costly for regulated agents, you also need to measure the outcomes. So you need to measure the actual costs for the regulated entities. Okay, so this literature on regulatory complexity, it needs actually to have good text-based measures, good outcome-based measures, and to study how both are related. Okay, that's how you can make progress in this literature. Second, if you think about these text-based measures, almost by definition, almost all of them, they depend very strongly on the way the regulation is written, okay? For instance, here I have measures that are more based on linguistics. It's, they are actually meant to capture the quality of the drafting, if you want, okay? So by definition, this is measuring psychological complexity, but not intrinsic complexity. And so that's why we think that, you know, the measures we are proposing, so potential and quantity in particular, are very interesting because they aim at capturing intrinsic complexity. And that's something which is very rare in the literature, okay? These are measures that should not depend in theory on the exact way the regulation is written. And I'm going to show you some evidence that actually in reality, it does not depend too much on the way regulation is written. Okay, so we think that's actually quite important. Scott, are you saying you want to use complexity measures to predict regulatory costs? Yes, this is exactly what we want to do. Okay, so actually I'm going to show you an exercise, an empirical exercise at the end where I'm going to show you that we can predict a little bit regulatory costs. Okay, but I think this is what this literature should be aiming at. Okay, thank you. All right. Okay. So time is flying. So let me show I have time for everything. Okay. Just a proof of concept also to clarify, you know, this notion that regulations are a bit like algorithms. Okay. So the first thing we do, so we do a lot of crazy things in that paper. Okay. So the first crazy thing we do is we say, okay, let's take this concept very, very seriously that regulation is an algorithm. If that's true, we should be able to take an existing regulation and code it as an algorithm. Okay, so this is what we did. So we took the Basel I approach to computing capital requirements. So it's the first international standard for bank capital regulation, and we coded it as an algorithm in Python. Okay, so here you have the text of Basel I on the right. And you can see that this text, you know, implicitly is, you know, these are really rules to compute capital requirements. And so this is very, very close to an algorithm, okay? For instance, on the text on the right, you have, for instance, claims on central governments and central banks denominated in national currency and so on shall have a 0% risk weight. We code this as if the asset class is claims and the issuer is central governments or the issuer is central banks, and the denomination is national and the funding currency is national, then the risk weight is 0, okay? As you can see, actually, when you code it as an algorithm, you realize that it's a pretty complex conditional statement already, okay? Because the simple sentence implicitly has a lot of and or and so on, okay? And so, but fundamentally, you know, this is really a rule that you can understand as an algorithm. Once we have this, we can compute our measures. We can simply count the number of operands and operators in this algorithm and derive the different Halstead measures, for instance, for different asset classes or for different rules. Okay, that's one thing that we do. Sorry, and let me explain something else before. We can do that on the algorithm. Then we can do the same thing on the text. We can say, well, you know, the text is not an algorithm itself, but clearly, you know, if I look at this cash, I know that in the algorithm, it's actually an operand. Shall have, in the algorithm, this is the equal here, okay? This is actually an operator. 0% is also an operand and so on. So I can classify all these words in the text into operands and operators, and then I can compute my Halstead measures exactly in the same way, okay? We do the computation for the actual algorithm, we do it for the text, and we compare our measures, okay? In particular, we look at how correlated these measures are to each other. What we find is that the measure quantity is perfectly correlated almost by definition. Okay, so each rule has exactly one regulatory operator, regardless of whether it's a text or an algorithm. If we look at potential, it's quite strongly correlated, okay, more than 80%. And for potential, remember, this is this measure potential volume, which Halstead said, you know, should capture intrinsic complexity. So what's interesting here is that we see, you know, in a sense, you know, we have the same regulation, but in two different formats, okay? We have a text format and we have an algorithmic format, okay? In principle, if you have a measure of psychological complexity, it should not be the same, you know, it should be sensitive to the format you are using. It could be that the algorithm is easier or more complicated to understand than the text, okay? Because it's written differently. If you have a good measure of intrinsic complexity, then it should be the same ideally in the text and in the algorithm, okay? And we do obtain something like this, that indeed, you know, quantity is exactly the same in both cases, and potential is very correlated. It doesn't work perfectly for potential. The reason is that text leaves a lot of things implicit. Okay, when we code the algorithm, we have to make those things precise. As a result, the number of operands in the algorithm is higher than in the text, and that's why the measures are a little bit different, which I think is an interesting observation in itself. But what's interesting, I find, is that this analysis, supports the idea that indeed, quantity and potential are really better at measuring intrinsic complexity, whereas the other measures, they depend a lot on the way you write things, which is normal. Okay, they are measures of psychological complexity. Okay, good. Okay, let me keep that for the sake of time. Okay, so if you want this Basel I thing, it's really a proof of concept. Okay? We say, okay, if our approach should work, it should work in particular on Basel I, because Basel I is very close to being an algorithm in the first place. Okay, so that's why it's a natural starting point. Then the second question is, okay, but for Basel I, you had to translate the entire regulation into an algorithm. This is very time consuming. Okay, so we cannot do that at scale. So then the second question is, okay, can we, adapt this approach to a very large text? And so in a large regulatory text, classify operands and operators, and how is that going to work? Okay. So here what we did is that we consider the Dodd-Frank Act, which is a very large financial regulation text in the US. Many of you are probably familiar with it. And that's what we do. Okay. So this is the tool that we developed to do this exercise. We look at the entire Dodd-Frank Act, and then, manually we look at different words or groups of words, and we classify them into operands and operators. Okay. And so by doing this, what we are doing basically is that we are building a very long dictionary in which we have all the expressions and words that appear in the Dodd-Frank Act, and we give them an algorithmic value. Okay. And so we are going to classify them into operands, regulatory operators, mathematical operators, logical operators, and then we have a bunch of things that cannot really be classified in this way, in particular references to other legal documents, function words, and things like that. Okay, but there are a lot of words that we can classify into operands and operators, and then we compute our measures exactly like I showed you in Basel I. Okay. There are some subtleties in this exercise. Okay, so if you are interested in applying this measure, you can look at how we do it exactly in the paper. Some difficulties. So, for instance, what about n-grams? Okay, so for instance, you have expressions like made of several words, like the Federal Reserve, for instance. Of course, Federal Reserve is only one operand. Okay, you don't want to count federal and reserve separately. Okay, so how can you do that? It's a bit complicated. So we did that in 2 steps. So first, since we classify things manually, we already manually identify a lot of n-grams like this. Second, we also developed a program where, well, it's quite simple actually. What the program does is that it checks for all the sequences of words of a given length that appear in the text, how many times they appear, and it returns all those that appear at least a certain number of times. Okay, so I can ask this program to tell me, okay, take all the sequences of 5 words that appear at least 10 times in the text and show them to me. Okay, it's going to give me a list of 200 sequences of words that appear exactly in the same order, at least, I don't remember what I said, maybe 10 times. Okay, and then I can look at all these sequences and manually identify which ones are actually, an expression, an n-gram, and should be an operand or an operator. Okay, it's a little bit time consuming because all of this is, there's a lot of manual work here, but we are not talking about a crazy number of hours. Okay, so doing that for the Dodd-Frank Act, it's, you need about maybe 1 week. Okay, and the Dodd-Frank Act is a huge document. Okay, so it's something a bit long, a bit boring, but we think, it's nice because there's a lot of manual expertise that goes into this, and it creates, a dictionary that you can use for many other things. Another issue is, what do you do with variants, for instance? And so here again, we look at them manually. That's again a little bit time consuming, but in nothing that cannot be managed. Okay. All right. The output is that at the end of the day, we have a big dictionary with almost 6,000 operands and more than 400 operators. Okay, so we make all of this available. So if you're interested in financial regulation, this is stuff that you can reuse. If you are not interested in financial regulation, be aware that the operators are probably very much the same in other fields too. Okay, because these are words like, shall, should, regulate, capped, all things that indicate a regulatory operation. They are going to be used as well in any other field of regulation that you can think. Okay, so we think that they can be, those have a lot of external validity. Okay, I have 10 minutes left. Just let me show you, how we validate those things. Okay, so we have two ways to validate our measures. One is experimental, the other one is empirical. Okay, so first the experiment. So I think this is very interesting. So for all of you who are interested in measuring complexity, I'm sure that you all have had this question, how do we know that your measure makes sense and that this is capturing something real, okay? We think there are two ways to do that, and both have pros and cons, and so that's why we do both, okay? So what they do in computer science is typically they run programming experiments. So they give, an algorithm to different programmers, and they look at how much time they take to actually code the algorithm, whether they make mistakes, and so on, okay? We follow the same idea. What we do is that we generated a lot of random regulations, which are random variations on Basel I, okay? So that's a bit crazy, basically. We built a tool that can generate random financial regulations. Why random? Because then, we don't want the results to be biased by our own knowledge, okay? So we want to be completely agnostic on the regulations. So we generate them randomly. We select, 38 that make sense in the sense that they are not contradictory in particular. And then we asked 150 of my students to actually follow the rules in those random regulations and do a regulatory computation, okay? We measure whether they find the correct answer and how much time they take, okay? So basically what we have is we have a sample of 38 regulations. For each regulation, we have different measures of their complexity. And then we see the time taken by students to do the associated computation and whether they found the correct result or not, okay? So we have a text-based measure and we have an outcome. And so we can see whether the text-based measures predict the outcome, okay? All right, if you are interested, actually, you can go on this website. It's called regulatorycomplexity.org. You can log in with this account, password test, and you can play this little game and see if you can beat our student, okay? All right, so, okay, let me jump into the results directly. Okay, so the first thing I report here is we try to see whether the different measures can predict whether the students find the correct answer, okay? And so in the first column, you will try to predict that just using the length of the regulation, okay? And you can see that, well, it works, okay? Length is actually a pretty good predictor. If length increases, indeed, the probability that the student is going to find the correct answer increases, okay? Then we add our other measures on top of length. Why? Because, length is a very easy measure and it's very much used in the literature. So if you propose some other measures, you have to show that they capture something that length is not already capturing, okay? And so which ones are working well here? Well, the one that works well is quantity, okay? Because quantity, indeed, captures, predicts outcomes beyond length. Actually, when you include quantity in the regression, length is not significant anymore. And remember that quantity was supposed to capture a different dimension. It was supposed to capture intrinsic complexity, okay? And so here we see that actually it shows up as the one that works best in this exercise, okay? All right. Then we can look at the time taken to answer, okay? So it's a measure of the effort that students had to exert in order to answer the question. Here we see again that, length has an impact. It's very easy to interpret, actually. If you have a regulation which is 1 word longer, the student is going to take, on average, an additional 3 seconds to give an answer, okay, from an average of 132 seconds. Okay, it's quite big, actually. But if you measure quantity, if you have an extra word and this word is a new economic operand, it's something that does not appear in the rest of the text, then it's 13 seconds. The impact is much bigger because you are like asking the student to consider another concept even, okay? So it's not longer, it's longer in a way which is even more complex. And potential, the number of rules, also works quite well in this regression, okay? And again, quantity and potential are here the two measures that work very well, and these are the measures that were supposed to capture intrinsic complexity and that were supposed to be different from length, okay? So we think this is a good validation of our approach. And then, because I have very limited time, we can also do that empirically, okay? So here, the idea is we have text-based measures and we want to show that they predict outcomes, okay? So I showed you experimental outcomes. The advantage of this is that the key advantage of the experiment is that the regulations are randomly generated, okay? Their complexity differs in a kind of random way, which should be uncorrelated to anything else, okay? So that's very nice. The problem, of course, is that, well, these are kind of toy regulations that are very short, and this is with students, who are not experts or whatever, so the external validity is maybe, not the best, okay? That's always a concern with experiments. With empirical validation, we are going to do an empirical analysis of actual data, okay, not experimental data. And then the pros and cons are reversed. The advantage of this is that this is, well, actual field data. So we know that this is the actual complexity as perceived by professionals in banking, okay? So that's good. What's bad is that the regulations that the empirical analysis relies on are actual regulations, so they were not randomly generated, okay? And so in particular, what this implies is that it could be, if you have a regulation that is extremely complex, that, for instance, is extremely long, probably, the regulator knows that it's extremely long. And so the reason why the regulator made the regulation long is it's probably for a reason. It's not exogenous, okay? And so that limits a little bit, the statements you can do about the empirical analysis. That's why I think it's good, to do both because they have different advantages and disadvantages, okay? So what do we use? We use the implementing technical standards of the EBA, okay? So those of you familiar with the European Commission and European institutions are probably aware of this regulation. So these are basically, very long reporting templates that all European banks have to use. And the EBA ran a very interesting survey where they asked all the banks in the EU to tell them, which rules are more complex. Okay, and so this data is public. And then what we do is that we measure the complexity of each of these technical standards, and we correlate that with the answers given by bankers. Okay, so in particular, we try to see whether having a high text-based measure of complexity predicts that a lot of bankers are going to say that this rule is complex. Okay, and so this is what we find. So this is one of the main tables we have in the paper. The units are not very good. You see a lot of zeros, but that's because these regulations are very long. So maybe we should do that in thousands of words or whatever. But what matters is really, the science and the significance. And so what we find is basically, very similar to what we had in the experiments. In particular, that the one measure that does very well and captures complexity beyond the length is, again, a quantity. Okay, the number of different rules in a given template. This one shows up quite strongly. Okay, so it's a measure which is supported both by the experiments and by the empirical analysis. Okay, so we think it's actually a good validation of this particular measure. Fortunately, it's also a measure which is relatively easy to compute because it's only based on what we call regulatory operators. So all the words that indicate a new rule or a new obligation for a regulated entity. And those words, typically should not vary too much across industries. So if you are interested in that measure, you can actually, reproduce it in other fields. Okay, I'm out of time, I think. So let me conclude. So I tried to show you a new framework to conceptualize and measure regulatory complexity. I was probably a bit quick. I'm sorry. There is, we have been working on this for a long time, so we have a lot of stuff to show. I hope that you found some of it at least interesting. And we think that, this work, hopefully it opens up several interesting avenues for research. I think it opens up, new ways of measuring the complexity of regulation and think a bit more empirically about the determinants and the impact of regulatory complexity. And another idea which I think is interesting is to try to develop applied tools to help policymakers manage this complexity. Okay, so a little bit like, you have, online tools that tell you whether the text you are drafting is too complicated or could be simplified and so on. Regulators could have access to something maybe a bit similar. So that's potentially, like an interesting output for this literature on regulatory complexity. All right. Thank you very much. Thank you for your attention, your comments, your questions. And, if there is anything else, feel free to ask me.
Okay, thank you very much, Jean, for this very interesting presentation. We are a bit limited of time, but to still have some room for questions.
I'm sorry I was too long. That's my fault.
No, you did an excellent job, and take your time. Thank you so much. Nir, you go.
So any questions? Please raise your hand or just jump in. Okay, if not, I will just start with a very simple question. So just if you could a bit discuss the decision to go for dictionaries, not for other NLP approach, LLMs. What was the considerations behind it?
Right. I think that's because, so we are not data scientists or linguistics researchers and so on. We are finance professors. So we thought that, our comparative advantage is really on the field expertise, basically. And we thought that it was interesting, to use that to compute this dictionary. Also, I think when we started, it was a long time ago. So at that time, it was a bit less common to use this type of methods. But so more fundamentally, I think this approach is really about classifying into operands and operators. So that's not, that's something, that's very different from topic analysis or these kind of things, right? So maybe there is a way to automate this classification. But I think in order to automate this classification, you need to have a training sample. So I think, for instance, one nice way of extending this research would be to use our dictionary as a training set for a machine learning algorithm that would then classify into operands and operators in a different sample. Okay, but we thought a little bit at the beginning, can we think of rules to automate the classification? That's not easy at all because it's a bit context dependent. So yeah, if you see other ways of doing this, and you can simplify my life, that I'm very open.
Yeah, you can perhaps discuss it further in email or whatever. But I have another question, which I was also considering. So legislation can be bundled in very different ways. For example, we have this Dodd-Frank, which is extremely long, and in other fields or policy areas, we might have instead 30, 50 separate laws. And I was wondering, how does your framework actually account from very different pieces of legislation that can specifically target the same issue compared to mega huge laws that do it in a very long way? Do you have any idea or any?
No, that's interesting. So that's the question a bit of the corpus selection, if you want, right? And so I think this is where field expertise is very important because, as you said, for instance, even for banking regulation, that's exactly the same thing, right? That there are many different regulatory texts. And so if you want to measure the complexity of the entire banking regulation, you need to be aware of all the relevant texts because otherwise, depending on, of course, if you have only a partial view, you are not going to measure things properly. So so I think it's the correct approach is it depends on what you want to measure exactly. But if you want to measure the regulation for a given industry, you definitely need to know what are all the relevant texts, and depending on the industry, it could be that there is one big text or many small ones. and that's part of the difficulty. That's also why I think it's, you know, there is some research in finance and in economics doing a lot of analysis like across industries, and so I think this is very difficult to do in general, because without the field expertise, you might face exactly the type of issue you are describing, that, you know, you think that all these industries have a regulatory process which is comparable, but actually this might not be the case, and you might not be aware of that, right? So that's, I mean, again, it's our pros and cons of different research approaches.
Mm-hmm. And one maybe last question from my end. So you mentioned also some works in other fields, other policy areas. Any ideas about the particularity of financial regulation compared to other areas? What makes financial regulation perhaps more complex? There are other fields. Do you have any thoughts about that?
Yeah, so that's a good question. So in finance, people have this impression that financial regulation is much more complex. To be honest, I'm not completely sure. I think if you talk to people in the, you know, I know in the aeronautic industry, they would tell you that it's extremely complex too. In the food industry, in pharma, in whatever, you know, I think it's relatively common actually that an industry is regulated in a very complex way. Maybe something which is a bit specific about finance is that I think the debate about the complexity of financial regulation is there is much more public debate about this. So it's a much more political issue. And so that changes I think it changes the impact of complexity a little bit, because, for instance, you know, among the different theories we have about complexity of regulation, there are some that say, you know, one of the costs of regulatory complexity is that it's going to lead to regulatory capture. That, you know, the problem with banking regulation is that it's so complicated that it's a discussion among experts where even the regulators themselves are not completely sure of what the regulation says. So the bankers have a lot of say in the debate and so on and so on. It's probably true in other industries, but I think in finance, it's probably even more true than in some others. And also you know, the amounts at stake are very large. So what we know in finance is that, you know, if you don't regulate banks properly and they take too much risk with the implicit backing of the government, what's happening is that implicitly you are transferring hundreds of billions of dollars of you know, public money into the banks, but nobody sees it. It's because, you know, as long as the crisis does not hit, you don't realize that all this money is at stake, right? And so that, you know, again, it's not the only example. There are other industries that are very important and so on. But I think the debate in finance is just a bit more salient, and the stakes are maybe a bit higher than in some other fields. But maybe I'm very biased because I'm a finance professor.
Okay, thank you. Any more questions before we end the session?
Could I pose a question?
Yes, please.
This is Scott Jacobs. Professor Colliard, thank you very much. I have two questions for you. One is, it was implied in your last response. Can we relate measures of complexity to market outcomes such as market structure, competition, barriers to entry, innovation? And my second question is, what's implied by this work is that there's a moment of declining kind of marginal utility of additional regulation, that at some point, the reason for my earlier question was that at some point, each additional regulation actually reduces the effectiveness of the regulatory stock to which it is added, that there's some natural limit of regulatory absorption or the absorption of complexity in the industry. And so, this would affect compliance. And I know that some of these issues came up in the 2008 financial crisis in the United States with respect to the complexity leading to, you know, gaps in particularly the risk modeling or risk management of these novel secondary, you know, derivative instruments in the market. So is there, in your view, some optimal complexity? And if so, can we develop these tools to the point where we could say to a government that you have reached in this sector or field some point of complexity beyond which you are actually reducing the effectiveness of regulation or increasing the risk of regulatory failure
Right.
But what are your views on that?
Okay, so that's really a great question. It goes well beyond this paper, right? Which is more like a measurement paper where I try to show, look, this is a measure, and it kind of makes sense, and here is why. Okay, and so it's we do a lot of things already, but it's a bit limited what we can say. But indeed, so at the end of the paper, what we do is we try to propose a research agenda, which is exactly what you just said. Okay, so in the context of financial regulation, what we do at the end is that we propose, as a kind of proof of concept, if you want, we propose a very simple normative model of capital requirements. And so in that model, you can choose a regulation which is more or less complex. We can measure the complexity of the regulation. And then you have this trade-off between, you can have a more precise regulation, but then it's going to be more complex and there's going to be more mistakes and that's more costly. Okay. So there is this trade-off between precision and complexity. And of course, we cannot say, for the moment, we don't have the ingredients to really do this exercise as we should, but we see that as describing, a research agenda, if you want. What are the ingredients that you need? And so what you need is the measures of complexity based on a text. You need a normative economic model to tell you what's the benefit of a more precise regulation. You need to have empirical measure of the cost of this complexity. You need to have, empirical research mapping the text-based measures into those costs. You need a lot of things, basically, right? But in principle, that's possible, right? And so but yeah, it's a collective effort. So our hope is that others will pick up on this, and that there can be more work. Because, for instance, if you think about I think for regulation, if you think about other policy decisions in economics, one which has become very quantitative and very scientific is monetary policy. So now you have, complex models of the economy, very quantitative. You tell the head of the central bank, look, these are our forecasts. If you do an increase in interest rate, this is what you are going to obtain with a certain probability and so on. Okay. For regulation, in principle, you could do something like this, including the complexity, but this requires a lot of ingredients that for the moment have not been fully developed. Okay, but I think if we are very serious about the regulatory process, we should aim at having this type of stuff, basically.
Okay, I think a lot of there are a lot of other topics to discuss and a lot of questions ahead, but we need to end up now. Thank you so much, Jean, for this really interesting session. Your paper I just shared the link for your paper here in the chat. Thank you again for
your working paper version. So we are.
Oh, okay.
We are under revision at the Journal of Financial Economics. The reports are in. We are just waiting for the decision of the editor. So it's like any minute now. So
okay, crossing fingers. So we have another session next week. We'll publish the details soon. And thank you so much. We look forward to your participation also next week and in next sessions. And have a nice evening, good afternoon, good morning.
Thank you, everyone. And thank you so much for all the comments and questions. Very well appreciated. And thank you for the invitation again. Have a great day, everybody.
Thank you.